Hello everybody and welcome to this nice tutorial for IEC61850. Today we would like to configure reports on SEG protection devices. Some people ask me how to prepare reports and how I can work with the IEC61850 inside of the SEG electronics devices. Today I would like to show you how to create this reports, and for this we are using three parts of software. The first is the SmartView software from SEG. The second one is the ASE-61850 SCL-Manager, and the third one is the IED Explorer. So at this point, a very big thank you to SEG Electronics, because they provide me a device with IEC61850 protocol. And a special thanks to ASE-Systems, they provide me this SCL-Manager that I can show you this on this video and perform this nice trainings video. But now let's start. You see I have opened the SEG SmartView software. First I connect to my device. Because I need the data tree of the device, I need to create our IED file from this device. This is important because I need the IED file to create a substation configuration, to create my reports and re-import it to my protection relay. With the SmartView software, we are doing the configuration on the device. With the ASE software, with the ASE software, we are creating the substation configuration, and with the IED Explorer we are checking the working of the reports. Now you can see I've opened the parameter tree of the SEG electronic device. You can see we have the MCA4. You know, this is a protection device with a bigger display, and you can control up to 6 breakers in this case. Actually, I have only configured 1 breaker. This is enough to show you what have to do. So first we go to device para, IEC61850, and open the communication window. Here you can see the IEC61850 function is inactive. This is important. We cannot upload a new configuration if this function is activated. But now let's create the ICD file. I click on Create ICD file. The software creates this file, but it's only possible if you are connected to the device. It's not possible to create an offline configuration. Maybe in the future this will be a nice feature. This makes it more easier to prepare SCADA engineers her configuration. So let's give her a name. It's MCA4_1 ICD. I've exported my file. And now I will save my configuration in the SmartView software. With this you get the name of the device, the software version. So here you can see the name. You can see the name of the device, the software version, and the serial number from the device. This is a very nice feature. So now we change from SmartView software to ASE IEC61850 SCL-Manager. I bring it up front. This is the manager. In this tool we will create our substation configuration and we will create the reports. Let's start. We click on New Project. Let's say it's IEC61850 demo version. I choose a new folder where I save my project. And I click on OK. Select project type. I think in our case we have a simple substation, and we use the edition 1 because until today the SEG devices only supports the IEC61850 edition 1. And then we click on OK. I know from SEG that they are working on edition 2. Hopefully it's coming very quickly. Here you can see my project is created. The first what we have to do, we have to create our substation network. For this we click on Project, make a right click, and click on Network Addressing. Here you can see there's no substation configuration inside, so we have to create a one. We click on Add. Let's say we have IEC subnet, for example. We have up to 100 megabit, so we change from 10 to M. Station bus is a simple text, the rest is okay and can stay as it is. Click on Save. Now we have created our substation network. The next what we would like to do is we import our device. So we import our ID file. We click on ID and Add ID. And now we can choose Create New, we don't have. Import from database, we don't have this device in our database. So import from file or folder. We use this one, we click on Next. Here we choose Browse. And now we will go to our folder where we have stored the ICD file. Here you can see the ICD file that we created in our SmartView software. We click on that and say Open. Now you can see the file was prepared to import. We have an ID name. It's a simple name is template. It's from all SEG devices. So let's change it to MCA4_1. It's instant 1, the validation was okay, and now we have to change the network because we have created a network before, and here we click on IC subnet. And that's all. Let's click on Next, and finished. You see the import is done, everything is fine. We can for now we can close the network addressing. Now we make a double click on MCA4_1. Double click, and now you can see we have the communication settings. You see we have here our select network. Now we have to give the device the specific IP address. On my device it's 192.168.25.64. Maybe your device had another IP address in your subnetwork. This is up to you, you have to change it. This is a standard private network. Let's 255.255.255.0, and I have to add the gateway 192.168.25.1. And very important, here you have to click on Save. A lot of times I forgot to click on Save and then I got a validation error on the device. Click on Save, parameters are set. So the network communication is prepared, everything is fine. The next what we have to do, we have to create our data sets. Inside our data sets, we have the information we would like to transmit via the reports. So here you can see a lot of information, and here you also can see data set. So we click on data set. Nothing is inside. We click on Add. And here you can see we can choose the logical devices and the logical nodes. There are some logical devices inside of the MCA4. We have the CTRL for controlling devices. They are the information and the controlling of the circuit breaker. We have MEAS. MEAS includes the measuring for current, voltage and frequency. PROD includes the protection functions. DR for data records, that we can maybe download records in the future. And X for external communication like virtual I/O. You know, in the IEC61850 you can read and write logical I/Os on the device, and they are stored in the EXT. But the first data set we would like to control because we want the information about the circuit breaker. Okay, inside here we would like to give a nice name like DS CTRL, DS for dataset, CTRL for control. I choose the logical device control and the logical node for our circuit breaker. Here you have some information inside, and the feedback information we would like to become are in XCBR1. It's our first circuit breaker, which are X for that's controlled. I open it, and here you can see the possible values we can see on the device. Now we would like to have the position. The position, if you see, we have POS, and now we will add the value of the position to this data set. We click on, we add it to the data set. and we click on OK. That's our first data set. It includes only one value. The next data set we would like to create contains the measurement values. Well, again, we click on Add. Now we are going to the logical device MEAS. We put it in the LLN1, LLN0. Click on OK. We give it a nice name like DS MEAS. It's very important. You can put a lot of. It's very important that you have a nice structure in your data sets, in your report control books, for that other people can read your configuration. You can put all. It's possible to put all your information in one report, and you can subscribe this report. But this is, from my point of view, this is very unstructured. So we click on logical device MEAS. On logical node, we click on our measurement. STA is for statistic, and MXU is for measurement. So V for voltage measurement, C for current measurement, P for power measurement. And EC is for earth current measurement. So we click on V for voltage. And here you can see the information we would like to have. I close ST. I go to phase-to-phase voltage, phase A to B, and I use the C values, the magnitude and the angle. I don't use instant values because this is not so nice on reports. You have all the time you have communication on the subnetwork. That's not so nice. On C values you have a dead band only if the voltage or the current will raise below or behind, or let's say, sorry, if it raise above or go below this dead band, then it will become an update on the report. Let's go to phase B to C. Also not the instant C val. We use the C val, magnitude and angle. The same for the phases C to A, magnitude, angle. The same we would like to have to the phase to neutral voltage. Here we choose also for phase A, magnitude and phase angle. On phase to neutral B, C val and the angle. And the same for the phase C. The magnitude and the angle. Also the neutral voltage could be interested, so we use them too. Also the frequency is interested. So the next what we would like to become is the current value. So we go to CMMXU for the current. It has the same structure, very simple. We close ST. Here you can see the current for phase A. We also use the C val, the magnitude, the phase angle, phase B, and phase C. The neutral current, and that's it. Now we can use additionally the power. We go to P, and here you can see the total active power, the total the total reactive power, and the total appearance power. And let's click on OK. We have defined our second data set. Now we put the third data set with the protection information. We go to prot for protection, LLN0. Here we choose DS prot. We choose the logical device prot and the logical nodes. Here we have some logical nodes. Actually, we have only the two overcurrent stages. And this you can see with P for protection, TOC, time over current, stage 1. And here we would like the pickup and the trip information. The same we would like to have for the logical node 2, for the second overcurrent stage. And here also we use the pickup and the trip. Let's check what's in HMI. Is there some information? No, there are no informations inside. And that's all from my point of view. Let's click on OK. And now you can see we have 3 data sets. One for the circuit breaker feedback. If one circuit breaker, maybe you could put it in another data set, but I think let's make a nice structure for engineering and documentation. That's CTRL for the circuit breaker, MEAS for the measurement, and prod for the protection devices. The next step we have to do is to click on Save. And then we go forward and we create our reports. You see there's nothing inside. Inside our reports we define how we communicate with the device, or let's say how we get the information from the device. So we click on New. Now we would like to place this report for the control in LLN0, the same like the dataset. We give them a nice name like RCB for report control block, CTRL. We raise the revision. We choose our dataset. You can see only this dataset because it's in the same logical device. Yes, we say it's buffered. Integrity period 60 seconds, so every 60 seconds the values will automatically updated and sent to the SCADA system. Buffer time 2, it's okay. So the trigger options we need to use. The data change is okay, quality change is also okay. Data update, yes, this is very important. And the GI, we disable the GI because the SEG devices in edition 1 actually does not support the GI. The next what we have to activate and deactivate is in the option fields. We deactivate the sequence number because the SEG device does not support them, and the buffer overflow, they are also not supported. Next what we have to do, we make the report ready for enable. We activate this and we reduce the number to 1. That only one connection to this report is allowed. Click on Save. So you see, quite simple, we have created a report that is connected to our dataset. Now we create the next report, we click on New. Now we are going to the logical device MEAS because we want to have the measurement. We click on OK. We give it a nice tune name, RCB MEAS, revision 1. DS MEAS, buffered OK, 60 seconds OK, buffer time is also OK. We activate the update and deactivate the GI. We deactivate the sequence number and the buffer overflow. We activate the report enabling and we reduce it to 1. Click on Save. And now the last one for the protection. We click on New. Prod for the logical device. RCB prod. Same like the other one. And we click on Save. Now we have created our 3 report control blocks. They are connected to our 3 data sets. From this point of view, we have finished our configuration for the substation communication. Very important to know is we are using dead bands for information. So dead bands mean if we have a voltage of 10,000 volts and we say we have a dead band up to 100, that the voltage update will only, how I can say it, will only performed if the voltage raised above 100 10,100 volts or below 9,900 volts. If you want to change this, you have to go to logical nodes. Here you see your logical nodes. For CTRL we don't change, like we go to MEAS. Here we have the voltage. And inside of the voltage we have the CF, phase-to-phase voltage, phase AB, and here you can see the deadband. Actual it's working with volts, so this means 1000 volts. And if you think 1000 volt are too much, you have to go to you have to perform a right click, set value, and reduce it to 100, and click on OK. But I see in this editor this is not so nice, because every time you have to go back and reopen your tree. You see, I have changed it to 100. This is for the voltage, and this is for the phase angle. The same I'm doing here. Maybe it's quite easy to make this in an XML editor. This is quite faster if you know where you have to change it. This is not nice. But okay, it takes a little bit time to make the changes. So you see, I've changed my deadbands from 1000 to 100, so my deadband is quite small. Normally I have to do the same for the current and for the power, but to save a little bit of your time, I will not do this in this video. So for now we can save our configuration. We have done this configuration. It's possible to export to an SCD file. To do this, we click on the SCL SCD file, right click, export. You choose the folder where you want to put it and put a given name, IEC Substation, for example, and click on Save. So we have finished our configuration in the SCL-Manager. Here it is possible to put a revision and a version and some information to your substation configuration. You can click on Add, and it will also put into the SCD file. The next what we have to do is we have to change the SCD file manually. Why we have to do this? Because it looks like there's a validation error inside of the SmartView software. I will show it to you. I'm still connected to my device. You can see it here in this area. I'm still connected. Now I click on Send IEC61850 configuration. Now I choose my configuration. You see here it is IEC Substation SCD file. Click on Open. And you see here some validation errors. The validation is failed. Now we can check what's happened. Oh, there's something happened here. Here you can see we have trigger options, but it's interesting because we have deactivated this trigger option and set it to false, but the SCD validator say I don't allow it because it's inside of my configuration. We have to remove this. Attribute val import, it's not allowed. Okay, for now I will make a break on this video because I will check this one, what's happened on this. Okay, I have found the reason what what's happened with this? This was a value that was added by the SCL-Manager because we have changed the deadbands inside of the manager, and this parameter was added, and so we have to remove it manually because the SCD validator from SEG does not allow the import. So for this we have to choose a nice text editor or XML editor. I will use the Notepad++. Let's say click edit with Notepad++. Here you can see your IEC61850 SCD file. I click on Alt0 to reduce the tree. I click on SCL. Here you can see the header, the communications, the ID name. I open the ID, the access point, the server. And now the first what we do, we will reduce the trigger, this error with the GI and the buffer overflow in the option fields. So to do this, we are here back in the Notepad++. Here you can see the logical devices CTRL and MEAS and prod. First we will open the CTRL. Here you see the LLNO, logical node. And inside of this logical node you can see here the report control block. So we open the structure of the report control block, and here you see the GI. So we have to mark the GI and delete it. The same for the buffer overflow, mark it and delete it. This we have to do for all three report control blocks that we have created. The next we go to MEAS, LLN0, report control block. We mark the GI and we delete it. The same for the buffer overflow. Now we're going to prod, LLN0, report control block. We mark GI and we delete it. After this, we click on Save. And now we go back to the validator and check if we have reduced our faults inside of our configuration. We click on Select on Existing and choose again our configuration, and we click on Open. You see the validation not fails because let's say we have a non-nice error. We can use this error. It's not important for the devices, but it's not so nice. So let's try to upload the configuration. If not, we have to go back to our configuration, reduce the tree, and we have to go to the area where we have the measurement with the deadband. They are contained in MEAS. See the report control block, the data sets, and here are the measurements. And here you see the voltage measurement. We open the tree for voltage measurement. You can go to face-to-face voltage, SDI phase AB, and here you see the deadband. And this is the value that the SCL validator from SEG does not like. So I will delete it, and I will do this for all the other things. I reduce my tree, go to the phase to neutral voltage, and here I will do the same. So from my point of view, this is not nice that the SCL validator not works in this direction we thought about it. So it's not nice for Scala Engineer to work in XML files. Hopefully this will be fixed in the next version of SmartView with the validation. Here's nothing inside. Okay, we can save our configuration. Again, we go back to SmartView, select an existing, and we choose again our substation. We say open, and now you see there's no validation error, and we can send the configuration to the device. We enter the password The password, the standard password you can find in the user manual. The file was successfully uploaded to the device. We click on OK. The next what we have to do is we have to activate the communication. So we click on Function, choose Activate, OK, and then we upload it to the device. Yeah, we want to override the setting. It's transferring. This takes a little bit of time. We click on Save. We've now override our file. Now we can check if the IEC61850 is working. We click on Operation, Status Display, IEC61850, and State. And here you see the state of the IEC61850. Goose does not work because we have not configured Goose, but you see the MMS server is working. This contains the report, and they're ready to become contact. Okay, now the device is prepared for communication with the substation management or the SCADA system. So let's try this. For this, I use the ID Explorer. You also can use the ID Scout from Omicron. It's also a very nice tool, but the ID Explorer is free of charge. You can see the program. I have put my IP address inside, and now I click on Run. You see it connect to the IEC61850 device on my MCA4. This takes a few seconds to download the tree for the first time. So you see here's my device. Inside of the device you see the logical nodes. I open the logical nodes. Here you see the data sets and the buffered reports. I open the data sets and the reports. So now you can click on the data set. You see some information here. You can say right click and say Activate Reports. On the ID Scout it's called Enabled. The next we click on MEAS, Dataset Buffer. We click on the dataset, right click, Activate Report. The next we would like to do for the protection, we go to Prod, Dataset, click on this and Activate Reports. Now we have activated all three reports, and now we can simulate what's happened. We would like to see what's happened. For this we go here to the report view. Maybe in the ID Scout or your software it's a little bit different. And I click on Start Report. And actually you see nothing because nothing happens on the device. The device will only send information to you in case of data integrity or in case of data changes. For this I would like to simulate this. The SmartView software has the let's say the SEG device has a possibility to simulate values. I have prepared this. Now I go to SmartView software. I reduce the size that you can see both. Now I go down to Service, Test, SGen. SGen is a simulating tool where you can simulate some functions. For testing purposes, this is very nice and okay. For running conditions and in production, you have to disable this function to keep it secure. I click to Process, Start Simulation, Execute immediately, yes. And here you see the information has transmitted to the device. So what do we see here? The first what we see is oh, I don't receive a timestamp. Maybe we have to change a little bit about, we have not only to transmit the magnitude, maybe we have to transmit the whole phase AB that we become the timestamp transmitted. Well, for the next time. But what you can see here, we have start our simulation. You see we have a change of the voltage. Here you see the voltage on phase AB, phase-to-phase voltage and the phase angle, B to C, C to A, and the phase to neutral voltages. A, B, and C. Oh, I forgot the phase angle on phase A. However, here you see the frequency and also the current. That's nice, it works very well. Then I have a fault condition. You see the time over current stage goes to pickup. Here you can see the pickup. Then you can see the change of the values for the current. And then after a time, you see with timestamp. It was transmitted with timestamp. Here you see the opt. So that means that this is a pickup, this is a trip. The trip occurs. And after that, the trip is gone, both goes to false, and the values change to normal. And here you can see the simulation was switched to 0, so there's no measurement, and they transmit this. They transmit only the 0 voltage as last change. As you can see, it's you can create very quickly the configuration of the substation with the SmartView software, the SCL-Manager, and to check it with ID Scout or ID Explorer. So, thank you for watching this video. I hope this was educational and helpful. Again, a special thanks to ASE-Systems to provide the SCL-Manager. Special thanks to SEG Electronics to provide the protection devices. So guys, if you see some more of these videos, please inform me what would you like to do. If you have any questions, put it to the comments or write me a mail. And thank you for watching. Have a good time.